Okay, hi guys. So in this video lecture, we'll be starting off with a new chapter, which is surface chemistry. So let's get started. So surface chemistry basically deals with various physical and chemical processes taking place on the surface. So it deals with various physical and chemical processes taking place on surface. Okay, so first let us see adsorption. So we have a solid absorbent like this. Okay, so this is absorbate particle. On the surface of this solid adsorbent, so it will look something like this. So we have this adsorbent, which is, let's say, some solid particle, and this actually adsorb some of the particles on its surface. We can draw these particles here as well. So these are adsorbate particles which are getting adsorbed on the surface of adsorbent. Okay, so these are adsorbate particles which can be solid, liquid, or gas. So adsorption is a surface phenomena okay, and we have on this adsorbent we would have unbalanced forces. Let's say this was adsorbent and this was adsorbate particle. So on this adsorbate particles occurs some unbalanced forces due to adsorbent. Okay, so adsorption in simple words is the accumulation of molecules, atoms, ions on the solid surface rather than in bulk is simply adsorption. Adsorption is accumulation of molecules, atoms, ions on the solid surface rather than in bulk is adsorption. Next we can write that adsorption of adsorbate particles takes place on the surface of adsorbent particles. So again writing it that adsorption of adsorbate particles takes place on the surface of adsorbent particles. Next, we'll be seeing the difference of adsorption with absorption. Adsorption and absorption. So this is a surface phenomena, and this is bulk phenomena. Next, adsorption is, let's say, an example of adsorption can be, let's say in a vessel we have H2OG and a silica gel kept in it in the vessel. So we have silica gel. So this H2OG particles begin to adsorb on the surface of silica gel. Okay, and in the example of absorption, let's say again we have the same apparatus in which we have the molecules of H2OG in the vessel, and we have anhydrous CaCl2. So you will find that CaCl2 absorbs H2OG particles. So this is a bulk phenomena, this is a surface phenomena. Next, let's say we have another apparatus in which we are passing impure water and we have activated carbon inside this vessel. These are activated carbon. Okay, and then after passing the impure water through this activated carbon, what we get is a pure supply of water. Whereas if we have, so this is the application of adsorption. On the other hand, the application of absorption can be, so we have this apparatus in which we have some packing material which is used for absorption. This is packing material, and in this vessel we are passing gaseous mixture of A and B, and or at the bottom we have rather after this gas pass through this packing material, we get the solution of gas A in the bottom, and gas B just can be collected from this nozzle. Okay, and a pump is also connected to it. Okay, so rate of adsorption decreases with respect to time and rate of absorption remains constant. Rate of adsorption decreases with time and on the other side rate of absorption remains constant. Okay, we can also have another term, desorption, which is just the reverse of adsorption. Reverse of adsorption. Okay, so with this we come to the end of this lecture. In the next lecture we'll be seeing more on surface chemistry. So till then, good luck and goodbye.